And so I'll come back to which ones we chose in a bit. So for us, we were looking at, okay, the other option is static models. So I could, and here when I say static, I'm going to start with just an assessment of DC power flow. So these are the super quick ways of assessing the power flow in your system. So a DC model. So great, reliably convert. I say converge, it's not really converging, is it? It's just like a direct solution. Very computationally fast. You can easily capture things like line overloads. So it's great. DC power flow will tell you the line loading. Like obviously it's inaccurate to some extent, but gives you a good estimation of line overloading. I can redispatch generators. I can deal with those kinds of things very easily. And it gives acceptable consistency with historical data. So there's been a lot of work looking at using DC models for cascading failures and looking at how does that match up with historical work. And it's pretty good. So maybe we don't need to worry about adding in all these dynamics. Some of the problems, obviously this neglects voltage deviations, reactive power flows, things associated with that. You can then fix that using AC power flow. So you can bring in some AC power flow stuff. But obviously the big one for me, neglected all the dynamics associated with it. And I guess the reason I'm concerned with dynamics, if I look at, I mentioned there was that the under frequency event in the UK, 2019. Now, that event, parts of the country tripped off. So some parts of the country experienced under frequency load shedding. Other parts of the country did not. So what that means is that in some parts of the country, the frequency dropped too low. And in other parts of the country, the frequency never went low enough to trigger that. They all have the same settings. So that means we've got variation, regional variation in our frequency within that system. If there was just one singular frequency, then everybody would have experienced that across the country. They'd have all experienced that under frequency load shedding. So I know there's regional variations in frequency. It's that kind of dynamics that I want to be able to capture. I want to see how does having an under frequency event in this part of the network lead to these people being tripped off, and that then having a stabilizing effect for another part of the system as well. I want to tie all of that together.